So one day you've got a great website idea and you started coding it. You spent a couple of weeks coding it, it now looks great, and now you want to share it with the world. So how do you do that? You would not take all the servers with high-end spec in the world. You start with one small server and you put your code onto it and you launch it. So in this video, let's see how that looks like and how it works in general once you've deployed it. Welcome back, engineers. Let's look at how a single server setup looks like. So when you put your code onto a web server, this is how it generally looks like. It's just a box, just like a local computer with a RAM, CPU, and everything. And everything that you need is running on this box. It could be a front-end server, it could be a back-end server, it could be some kind of Python scripts that you're running, it could be any cron jobs or even a database that is required to run it. So everything is in this box. So there is nothing outside of this world that is required to make your website work, right? So how does this work? So imagine we are the users and we are using maybe a mobile or a web browser on a desktop or a tab or whatever, and we are trying to access the server. So how do you do that? So we take some kind of domain name like www.google.com or anything like that. And when we request the google.com through the browser, it needs to know how to find the right location where the server is. So for that, there is the system called domain name system, which is DNS, which takes care of providing that address. So we ask the DNS, not we, generally the browsers have the technology to ask it. So I'd ask the DNS, give me the IP address for example.com, and we return, and the system returns some kind of IP address. And then we make use of this IP address to make a request. This is the location of our web server, right? This is where our app is running. And then we return HTML page, JavaScript, or whatever, right? So this is how generally the web works, right? Now let's take a closer look at what this DNS system is. So when we make a request to example.com, like I said, it is not a simple straightforward request directly to our server, which is here, but it goes through a DNS resolver. It could be your browser, which may have cached it already if you have visited it once. Otherwise, it goes through a DNS resolver. It could be your internet service provider who takes care of this. So the request goes here with this text example.com, and then from there we go to something called a root server. So this is a server that is being maintained by ICANN, and it takes care of finding the respective TLD servers, right? So TLD servers are top level domain servers, which are responsible for maintaining the different types of domains like .com, .in, .xyz or whatever, right? So when the DNS resolver asks the root server, hey, where can I find this example.com? It returns the respective TLD server. In this case, it is a .com server, right? So the response is .com server, and using that response, we ask the actual name server who is actually hosting this example.com. So this could be your GoDaddy or Google Domains or Squarespace or anything like that. So it is from here that we get back the actual IP address. Once we get the IP address, the resolver gives it back to the browser, and now the browser can make a request to the actual server where our application is running. And once we have the request sent to the server will respond back with HTML or JavaScript or whatever, and the response is displayed onto the browser, right? So this is how a general DNS lookup and query works, right? So now let's talk about why a single web server may not be enough, right? So what is wrong with a single web server? So it is a monolith system where everything is running, right? So your front end is there, your back end is there, and your database is also there. You have everything you need to run this. So what is the problem here? The problem is, one, it is a single point of failure. If this web server goes down, your entire website goes down, nobody can access it, and probably all your data, if not correctly managed, is also lost, right? So that is the main drawback of using a single server, right? It's a single point of failure. Another thing is it is not very scalable, in the sense that as more people want to use it, there's going to be more incoming traffic, and the web server needs to do a lot of processing to handle all these concurrent requests, multiple requests, and beyond a point, a computer cannot handle that load. So there is a CPU which takes in a certain number of requests and process them, and beyond a point, it cannot do that, right? So you need to add some more CPU. You need to add some more RAM into it. And that is something you can do for a certain period of time until the web server does not allow any more extension, right? There's only enough hardware that you can put into a box, right? So this type of addition of adding RAMs and CPUs or GPUs or whatever is called vertical scaling, right? So we are trying to scale it up vertically, and you can do it up to a certain point. But beyond that, you're going to start thinking about distributed systems, and you're going to start thinking about adding multiple points of failure. Like you want to avoid the single point of failure, right? So you want to distribute this traffic into multiple servers, and then you want to also secure your data so that it is not also lost in terms of a single point of failure, right? So we'll talk about all these topics in the upcoming videos, but for now let's understand that for a single server setup, it's a monolith, and everything that you need is running inside a box, and that can be a potential single point of failure, right? It works as long as it works, but beyond a point, it's better to invest into a distributed system, right? So in this video, we've looked at how a single server setup looks like, how does a web work in general, how DNS resolution works, and why a single server isn't enough. So it is mainly because it acts as a single point of failure, and also it is difficult to scale, right? So there is an issue with availability and there is an issue with scalability. That's why we start looking into distributed systems and multiple server systems, right? So in the next video, we'll see how we can handle more traffic using a concept called load balancer and multiple servers, right? That's all for this video, guys. Thank you so much for watching. Do leave a like if you found this helpful. I will see you in the next one. Cheers.